going to teach catalysis. Actually, this presentation will mainly include the introduction part of the catalysis. Mainly, I'll be focusing on introduction, types of catalysis, difference between heterogeneous and homogeneous catalysis, advantages and disadvantages of this both catalysis. Now, catalysis means the substances that alter the rate of a reaction are called catalyst. The substances should be chemically unchanged at the end of the reaction, and the process is called catalysis. Now we know the catalyst, how catalyst reacts, how catalyst acts. Actually, catalyst lower the activation energy of a reaction by introducing a new reaction pathway. We all know activation energy we have got in thermodynamics. Actually, the energy, minimum energy required for a reactant to convert into products are called activation energy. Is called activation energy, and catalyst decreases the activation energy by introducing a new pathway. Now, characteristics of catalyst include a catalyst remains unchanged in its mass and chemical composition during the reaction, and we need only a small quantity of the catalyst for the reaction. A catalyst does not change the value of equilibrium constant. Catalysts are specific in nature. This means every reaction is catalyzed by a specific catalyst. That is very important. Catalyst exhibits maximum activity at a particular temperature, which is known as the optimum temperature. Now, catalysis is divided broadly into two types, homogeneous and heterogeneous. Homogeneous means if both the reactant and the catalyst are in the same phase, then it is called homogeneous catalyst. And heterogeneous means the reactants and catalysts are in different phase. Now there are some other classifications also, like positive catalysis means if the reaction is accelerated by the foreign substances, it is called positive catalyst, and the phenomenon is called positive catalysis. And negative catalysis means if the reaction is retarded by adding the substance, then it is called negative catalyst, and the process is called negative catalysis. And sometimes the product can act as catalyst. The reaction is slow at first, but after sometimes when the product is formed, the reaction becomes faster. This is called autocatalysis. And then acid-base catalysis means the reaction is catalyzed either by acid or base. And enzyme catalysis means it is is the increase in the rate of a chemical reaction by the active side of a protein. That means the catalyst is a protein, and it is called actually enzyme. If the catalyst is protein, then it is called enzyme. The enzyme may be a part of a multi-subunit complex or may transiently or permanently associated with a cofactor. It is also known as biocatalysis. Actually, in biological field, it is mainly applicable. Catalyst parameters include activity. The activity of a catalyst depends upon the strength of chemisorption to a large extent. We know physisorption, chemisorption. There are two types of adsorption, chemisorption and physisorption, and catalyst activity mainly depends on chemisorption. The reaction must get adsorbed reasonably strongly on the catalyst to become active. Then selectivity. The selectivity of a catalyst is its ability to direct a reaction to yield a particular product. It is called selectivity. Then stability is the number of reactions performed by each active site before it decays or become inactive. Yes, after performing many reactions, a catalyst can become inactive, and the stability is called how much time it has performed the reaction. Then there are many theories of catalysis. These are intermediate compound formation theory. According to this theory, one of the reactant combines with catalyst to form intermediate product which carries out the reaction. Then adsorption theory tells reactants are adsorbed on the surface of the catalyst and form a film. Due to high concentration of the reactants on the film, reaction proceeds at a faster rate. Then again, modern adsorption theory, according to this theory, reactants are adsorbed at active centers, that is free valencies, etc., on the solid surface and form activated complex, which under strain forms new molecules and leaves the surface. This explains why finely divided catalyst has greater activity. Then energy activation theory explains, according to this theory, catalyst changes the value of activation energy, which can be crossed by the reactants easily, and consequently products are formed. Then already I have discussed homogeneous and heterogeneous catalysis. Now, what are the differences between homogeneous and heterogeneous catalysis? I am going to explain. The activity is comparable, that reproducibility, heterogeneous is difficult to reproduce, but homogeneous is easily reproducible. Selectivity, heterogeneous catalysts are difficult to control selectivity, but homogeneous catalyst relatively higher selectivity, easy to optimize various types of selectivity. Reaction conditions, heterogeneous catalysts need higher temperature and pressure and better thermal stability, but homogeneous has somewhat lower thermal stability. It acts on lower temperature and higher pressure. Then there are so many differences. You can look at this slide and you will know about the differences between heterogeneous versus homogeneous catalysis. And then what is the advantages and disadvantages? Advantages include all homogeneous catalysts. In case of homogeneous catalyst, all the catalyst is exposed to the reactant, easily modified. Reaction mechanisms are well understood by the scientist. Easy process of diffusion and heat transfer, well-defined active sites. And these are absent in case of heterogeneous catalysts. In case of heterogeneous catalyst, advantages is easily removed from products by filtration and easily recycled. But in case of homogeneous catalysis, these catalysts are very difficult to remove from the products for reuse. And heterogeneous catalysis disadvantage is that only effective on the surface. Reaction mechanisms are poorly understood in general and poorly defined active sites. Then what is the application of catalysis? Now catalysts are applied in different fields, and it is very much important. Actually, catalysts are applied in petroleum and energy production, chemicals and polymer production, pollution control, pharmaceutical and food industry, and there are several industrial industries where catalysts are broadly used. So this is in brief about catalysis. This is the introduction part only. So I'll be uploading more slides, more presentations, more slides on catalysis very shortly. Thank you.